Network layer devices. Three devices operate at the network layer: routers, layer 3 switches. The router is the device that connects multiple networks or segments to form a larger network internetwork. It is also the device that facilitates communication within this internetwork. It makes the choice about how best to send packets within the network so that they arrive at their destination. Several companies manufacture routers, but probably the two biggest names in the business are Bay Networks and Cisco. Bay Networks is a conglomeration of smaller networking companies bought out by networking giant Synoptics. Cisco has always been a built from the ground up router company. Both companies make other products, to be sure, but their bread and butter is routing technologies. Routers have many functions other than simply routing packets. Routers can connect many small segments into a network, as well as to connect networks to a much larger network, such as a corporate WAN or the Internet. Routers can also connect to dissimilar lower layer topologies. For example, you can connect an Ethernet and a token ring network using a router. Additionally, with added software, routers can perform firewall functions and packet filtering. Routers are probably the most complex devices on a network today. Consequently, they are likely to be the most expensive, but simple low-end routers have been introduced by Bay Networks, Cisco, and other companies. The Brouter is a unique device that combines the functionality of a bridge and a router. It routes most packets, but if it can't route a particular packet, it'll try and bridge it. Unfortunately, if you try to use a Brouter as either a bridge or a router, it'll fall short in the functionality of either. The Brouter was mainly used to connect different network topologies and to bridge them, but it is not used much anymore. Layer 3 switches. A fairly new network layer device that has received much media attention of late is the Layer 3 switch. Layer 3 part of the name corresponds to the network layer of the OSI model. It performs the multi-port virtual LAN data pipelining functions of a standard Layer 2 switch, but it can also perform basic routing functions between virtual LANs. In some workgroups, a Layer 3 switch can replace a workgroup router. The transport layer. The transport layer defines the protocols for structuring messages and checks the validity of transmissions. Transport layer concepts. Transport layer reminds me of what my old tech instructors used to pound into my head: reliable end-to-end error and flow control. The transport layer does other things as well, but the protocols that operate at the transport layer mainly ensure reliable communication between upper peer layers. The connection type. To provide error and flow control service protocols at the transport layer use connection services. The two types of connection services are connection orientated and connectionless. Connection orientated connection services use acknowledgements and responses to establish a virtual connection between sending and receiving stations. The acknowledgements are also used to ensure that the connection is maintained. Connection-oriented connections are similar to phone calls. You dial the independent recipient, and the recipient picks up and says hello. You then identify yourself and say that you'd like to talk about something, and the conversation begins. If you hear silence for a while, you might ask, "Are you still there?" to make sure that the recipient is still on the line. When finished, you both agree to end the connection by hanging up. Connection-orientated services work in the same way, except that instead of mouths, phones, and words, they use computers. Network interface cards and special packets. Connectionless services, on the other hand, don't have error and flow control. They do have one simple advantage: speed. Because connectionless services don't have the overhead of maintaining the connection, sacrifice in error control is more than made up for in speed. Name resolution. Transport layer also handles logical address and logical name resolution. In some protocols, an address such as 185.45.2.23 isn't the best way to reference a host. Some protocol stacks, TCP, IPX, and SPX, for example, can use transport layer logical names for hosts in addition to their network layer logical addresses. These logical names make it easier for you to find hosts on the network. At the transport layer, various protocol stacks implement a protocol to translate network layer addresses into transport layer logical names. Transport layer implementations. Because we discuss the other layers of the OSI model, let's take a look at the IPX, SPX, TCP/IP, and NetBEUI implementations of the transport layer. As far as the connection services for IPX, SPX are concerned, there are two transport protocols, IPX and SPX. IPX is connectionless and thus enjoys the benefits of connectionless transport, including increased speed. SPX, on the other hand, uses connection-oriented services. IPX SPX has no name resolution system by default. The functionality is employed when a network server is running novel directory services, NDS, and DNS directory services, which runs at the session, presentation, and application layers, can make requests of an NDS database. The TCP/IP protocol, like the IPX SPX protocol stack, TCP/IP protocol stack has two transport protocols: transmission control protocol (TCP) and user datagram protocol (UDP). TCP is connection orientated and UDP is connectionless. Some upper layer protocols such as FTP and HTTP require reliable connection orientated service and therefore use TCP. Other upper layer protocols such as Trivial File Transfer Protocol (TFTP) and Network File System (NFS) require increased speed and will trade reliability for that speed. They therefore use UDP. The NetBEUI implementation. Because it is based on the NetBIOS protocol, NetBEUI Network Bias Enhanced User Interface has datagram support and thus has support for connectionless transmission. It doesn't, however, have support for connection-oriented services. NetBIOS does allow hosts to have logical names using WINs, but the naming service, as with DNS, functions at the upper layers of the OSI model. The OSI model's upper layers. The upper layers of the OSI model deal with less aristocratic concepts, even though we're still discussing computer networking. The top three layers, session, presentation, and application, seem easier to understand because the network plus exam doesn't cover the upper layers, and many times these top three layers are grouped together. The following sections will give only a brief overview. Session layer. Protocols that operate at the session layer of the OSI model are responsible for establishing, maintaining, and breaking connections or dialogues This is different from connection services provided at the transport layer because the session layers operate at a higher layer and looks at the bigger picture, the entire conversation, not just one sentence. Many gateways operate at the session layer. The presentation layer does what you might think it does. It changes the look or presentation of the data from the lower layers into a format that the upper layer processes can work with. Among other services, the presentation layer deals with encryption, data compression, and network redirectors. In addition, the presentation layer deals with character set translation. Not all computer systems use the same table to convert binary numbers into ASCII. Most standard computer systems use the American Standard Code for Information Interchange ASCII. Mainframe computers and some IBM networking systems use the Extended Binary Coded Decimal Interchange Code. Two are totally different protocols at the presentation layer can translate between the two. The application layer defines several standard services that fall into categories such as file transfer, print access, and email relay. Applications that access these network services are located above the application layer, although some people say that applications are an extension of the application layer. Upper layer devices. There are only a few upper layer devices, none of which operate at any specific layer. Because they perform a range of functions for the network, they fall into a class of devices known as gateways. A gateway translates one type of network data into another. Gateways can be either hardware or software, but the most popular way to run a gateway is as a software program on a dedicated computer. There are many types of gateways, but the one most people think of is an email gateway. Email gateways translate email messages from one type of email system so that they can be transmitted on another. For example, from group-wise email to SMTP mail for the internet. So I'm going to leave it here today for this video. If you liked listening, please consider like, sharing, and subscribing. And thanks again for listening.